Hi, welcome back. This is Professor Ridge and today's lesson on section 7.6, solving radical equations. So we're now ready to solve equations that have these square roots in them, since we just covered how to add them, simplify them, multiply them, all that stuff from 7.1 through 7.5. So the first rule we want to talk about is the principle of powers. So if a equals b, then a to any power equals b to any power. So we can raise both sides to any power we want, provided we do it to both sides. Now, the thing to note about this principle, it's an if-then statement. It's not an if and only if statement. So we might have some problems when we're solving equations. Here, I'll explain it in a second. Okay, so let's look at this example. If x equals 2 and you square both sides, x squared would be equal to 2 squared, so that means that x squared would be 4. But if we were going to go the other way, if x squared is 4, and we want to go backwards, that does not mean then x equals 2 may not be true. Since x could have been -2, because -2 squared, -2 squared equals 4 also. So so we have a problem here that just because x squared is 4 doesn't necessarily mean that x is 2. But if you start with x equals 2 over here and you square both sides, you know that this x squared equals 4 would be a true statement. So it's a if-then statement, which means we just have to be careful when we go back. If we square both sides, we get an equation that's not equivalent to the original equation. So it's going to be a possible solution to the original problem, not necessarily it will be. So we just have to check. So having said that, when you raise both sides of the equation to an even power, that's the key, that might produce an equation that's not equivalent to the original equation. So in that case, a check is essential. So you have to check. We're going to make so basically when we solve it, the solutions are going to be possible solutions to the original problem, and then we got to check it in the original problem just to make sure it works. Okay, so and that's only essential when it's an even power. All right, so let me write down the rules for solving a radical equation, and then we'll go to it. Okay, here's exercise 11. We got the square root of y plus 5 minus 4 equals 1. So our first step is going to isolate the radical term. So we got the square root of y plus 5 equals 5. And then we're going to use the principle of powers. We're going to take both sides of the equation and raise it to the power whatever the index is, square root squared. So we're going to square both sides. If it's cube root, I would raise both sides to the third power. If there's a fourth root, raise both sides fourth power, so on. Okay, and remember the square root cancel each other. So we go at plus 5 equals 25. And now we have the resulting equation is just a linear equation, so we're going to use our techniques from beginning of the book to get the y by itself. So y is 20. Now this is just a possible solution. We know it solves the equation y plus 5 equals 25, but we don't know if it's a solution to the original equation. And since we squared both sides, we have to check in the original problem, because we can have some. What happens when you square both sides? You lose negative signs become positive, so you lose some information. So we have to check. And what happens is we call those extraneous solutions when you get a solution that doesn't work in the original problem, which means it's not a solution to the original equation, and you just throw it out. So square root of 25 is 5 minus 4, that's 1. So 1 equals 1, that checks. So y equals 20 is the solution to the original problem. Okay? So again, it's really important that you understand you have to check when you raise both sides to an even power. All right, let's try another one. At number 16, we got the cube root of x minus 2 equals 3, and as you can see, we have the radical term all by itself. So we're going to raise both sides to the index, which is 3. So we're going to cube the cube root. That cancels. We get the number inside. 3 cubed is 27. Now, again, we got a linear equation, so we just solved this one. So x is 29. Now, this one I'm not required to check to make sure, since I raised it to the third power, as long as I did everything right, this is the right problem. So this check is just to make sure I didn't do any math errors. I'm not worried about getting what I call extraneous solutions. We won't get any of those. So here I'm just simply checking to make sure I did it right. So that's 3. Check. Okay? So again, it's required that you check it if you raise it to an even power. To an odd power, you're just checking just like we would check normally, just to make sure we did it right. In number 22, we got 3x to the 1/2, and remember 1/2 power is just like square root. So we want to get that term all by itself, so subtract 12 from both sides. So we got 3x to the 1/2 equals -3. And let's divide both sides by 3 so I can get that square root of x by itself. And now I'm going to raise both sides to the second power. And you see x equals 1. Now again, that's a possible solution. So when I go to check it, we plug it into the original problem. So remember, x to the 1/2 power is the same thing as square root. So square root of 1 is 1 times 3 is still 3. 3 plus 12 is 15, which you can see is not 9. So that means this 1 is an extraneous solution. We didn't do anything mathematically wrong, but it was because of that. It was with the problem when you square both sides, it's an if-then statement. It's not an if and only if statement. So we have to check. So we throw that out and we say no solution. So to see the difference between this checking, it doesn't work. It means that it means that the original problem, this solution is not a solution to the original problem. It's not that we made any math error. Okay, so you got to distinguish between, making sure you understand what you're checking. If you're checking, just see if you made a math error. And if you go back and look through all the work, we didn't make any math errors. So that means that 1 is not a solution to the original problem. You throw it out, you have no solution. All right, let's look at 41. So I'm going to solve this one. Now, when you have two terms with that have radical expressions, what you do is you still just isolate one of them, which in this case, one's isolated. The square root of 4x minus 3 is all by itself. So my next step is I'm going to square both sides. So I square both sides. So square root on the left side gets us just 4x minus 3. Now on the right side, so in scratch work, you're going to go 2 plus, we're going to go 2 plus square root of 2x minus 5 times 2 plus square root of 2x minus 5 and FOIL it, right? Or use the square formula, a plus b squared is a squared plus 2ab plus b squared. That's the way I do it. So I'm going to square the first term, which is 4, plus 2 times the square root thing. That's just the way I think of it in my head. So 2 times 2 is 4 times the square root thing, plus b squared, so that's the square root thing squared, which just gives you the number inside, because the square and square root cancel each other. Now from here, see, we still have a term with the radical, so I want to get that radical all by itself. But before I do that, let's just simplify, combine like terms. So I'm going to get the 2x, 4 minus 5 is negative 1, plus 4 square root of 2x minus 5. I'm going to get all my x's, I want to get the square root thing all by itself. So get all my x's on one side, the 1 on the other side. Minus 2 equals 4 square root of 2x minus 5. Now from here, I'm going to square both sides again. So I square both sides. I'm going to use that formula again. I'm going to get 4x squared minus 2x times 2 times, and then times 2 again. So it'll be minus 8x plus 4 equals, now I'm going to square this 4 in the front, square the square root thing, so the square and square root cancel each other. We get the number inside. Now this is a quadratic equation. And the way you solve quadratic equation is get it equal to 0 and see if you can factor it. So first let's simplify everything. So it's 32x minus 80. Subtract 32x from both sides. So just to save space here. So that'll be minus 40x. Add 80 to both sides. So that's plus 76. Okay, I'm going to factor it. So that's 4x squared minus 10x plus 19. Okay, so actually I'm just reevaluating. Okay, I'm going to add, that's why I shouldn't have skipped that step, huh? I should add 80, which I did, but it's plus 4 plus 80 is 84. And this will give me 21. Let me factor it out. Okay, so now I'm going to factor. So we're going to get 4x minus 7, x minus 3 equals 0. We want factors of 7, or we want set each factor equal to 0, so of course that one gives us none. X minus 7 equals 0, or x minus 3 equals 0. So x equals, we're going to add 7, or we're going to add 3. X equals 3. Now again, these are possible solutions, so we need to check. So I'm going to check x, both of them. I got separately. So x equals 7, and I plug it into the original question. So 4 times 7 minus 3, does that equal 2 plus square root of 2 times 7 minus 5? And the answer is 28 square root of 25, which is 5. This one is 21 minus, 14 minus 5 is 9, which 2 plus 3 is 5. So check. So that one works. And then you got to check that x equals 3. And let's try that one. So it's going to be square root of 12 minus 3 is 10, or 9, which is 3. 2 plus 6 minus 5 is 1. And then that won't work. So they both work. So you can have any kind of combination. They can both work, one of them doesn't work, and or they can both not work. So you have to check them each individually. If they're possible solutions, you check them in the original problem. They both work. They're both solutions. So that's fine. Sometimes one works, one doesn't. Sometimes both of them don't work, and in that case it'd be no solution. Okay, but in this one, they both were solutions. Alright, so that completes the assignment for 7.6. Go to My Math Lab, or completes the lesson for it. Go to My Math Lab and complete your exercises there, and I'll see you next time.